Hi everyone, welcome to my video on classes and objects. So every program that you write involves at least one thing that is being created or manipulated by the program. And this thing, together with the operations that manipulate it, is called an object. So an object is characterized by its state and behavior. So a book has a state described by its title, author, whether it's on the shelf, and things like that. And it also has behavior such as going out of print. And so if we were to create a book object, we would implement all of these things into it. And also a variable that represents an object is called an object reference, and we'll get into that as we go on. And a class in Java is a software blueprint for implementing objects of a given type. An object is a single instance of the class. So we write a class and it has all of the data fields and instance variables that relate to the object. And the methods of the class provide both the behaviors exhibited by the object and the operations that manipulate the object. When you instantiate a class or create an object, you create a single instance of the class. And combining an object's data and methods into a single unit called a class is known as encapsulation. And so now we have keywords called public, private, and static. And the keyword public preceding the class declaration signals that the class is usable by all client programs. And if a class is not public, it can only be used by classes in its own package. And similarly, public methods are accessible to all client programs. So basically, if something's public, anyone can access it. Clients may not access the private instance variables and private methods of the class. So even if it's public, you still can't access the private instance variables and methods that are inside the class. And the restriction of access of these variables and methods is called information hiding. And in Java, information hiding is implemented through the keyword private, and private methods and variables in a class can be accessed only by methods of that class. A static variable contains a value that is shared by all instances of the class. Static means that memory allocation happens once. So if you need to do something such as accumulate a total, you can label that variable static, and so all of the methods will use the accumulated value instead of the initial value that was given to the variable. If a variable is declared static and final in a class, it can't be changed. So now, methods. All method headers, with the exception of constructors and static methods, look like this. So they have an access specifier, which is public here, a return type, void, method name, withdraw, and a parameter list. In this case, it's password and amount. So the first type of method that we will learn about are constructors. A constructor creates an object of the class, and you can recognize one by its name. It always has the same name as the class, and a constructor also has no return type. The first constructor we will cover is the default constructor, which has no arguments. So as you can see here, there are no arguments inside the constructor, and it just declares the password as an empty string and the balance as 0.0. So we could create an object for this class by saying bank account B equals new bank account and with the parentheses, and so this will construct a bank account object with a balance of 0 and a password equal to the empty string. So in this case, the parameters are string account password and double account balance. So the constructor sets password equal to account password and balance equal to account balance. Up next, we have accessors. So an accessor method accesses a class object without altering the object. So basically all it does is get some information about the object. So here we created two objects. One is B1 and one is B2, and they're both for the bank account class. And by saying B1.getBalance and B2.getBalance, we're able to access the balance by using this method, because the getBalance method simply returns the balance. And so an access method basically just returns information about an object. And the dot operator indicates that getBalance is a method of the class to which B1 and B2 belong. So a mutator method, which is another type of method, changes the state of an object by modifying at least one of its instance variables. So in this example, we can see that the variable balance is modified because amount is added to it. So instead of simply displaying information, this actually changes one of the variables of the object. And we can see the same thing here, where balance is actually modified by subtracting amount, or the overdrawn penalty. So static methods are methods that operate on the entire class. So before we learned about instance methods, which were methods that operated only on the individual objects of a class, and static methods affect the entire class. So a static method is declared with the keyword static in its header. For example, here we put static after public, and so this method has now been declared static. So here we can see that a static method is invoked by using the class name with the dot operator. So here we have the class name bank account followed by the dot operator and then a method from the class. So instead of having an object here, we have an entire class because static methods are used to manipulate an entire class. So up next we have method overloading, which is when two or more methods are in the same class and they have the same name but different parameter lists. For example, we can see here that all three of these methods are called product, but their parameters are different. The first one has an int, the second has a double, and the third has two ints. Java will determine which method we will be calling based on the number of parameters that you input. And next we have the scope. So the scope of a variable or method is the region in which that variable or method is visible and can be accessed. So there's a certain area where a variable or method can be accessed, and outside of that, no one can access that exact variable or method. So the instance variables, static variables, and methods of a class belong to the class's scope. And the scope is determined by an opening brace and a closing brace. So a local variable is defined inside of a method, and it can even be defined inside of a statement. And its scope extends from the point where it's declared to the end of the block in which its declaration occurs. So the scope is basically the block where the local variable is defined, and a block is a piece of code enclosed within the curly braces. When a block is exited, the memory for a local variable is automatically recycled, and so that variable no longer exists outside of that scope. Next up we have the this keyword. An instance method is always called for a particular object, and this object is an implicit parameter for the method, and it's referred to with the keyword this. So when we use the keyword this, it can refer to the current object that we created. So in this example, we have a method called printPerson, and it prints this. So we could see that when we declare an object of this class and we call the method printPerson for that object, it will run this statement, system.out.println this. And that basically means that the method will print the current person object. So since we declared that the string is Dan and the integer is 10, it will print Dan 10. So another instance where this keyword is useful is when the name of the parameters that you declare inside of a constructor are the same as the private instance variables that you declared. So in order for Java to know which variable you're referring to, you use the this keyword, and we can say that this.num equals num. So this.num refers to num here, and this.denom refers to denom here, and it sets that equal to the private instance variables inside of our class. So up next we have references, and so all of the numerical data types that we've been using, such as double and int, and char and boolean, are primitive data types, and all objects are reference data types. And the difference is in the way that they are stored. So for example, variables can be thought of as memory slots, and if we declare two variables, num1 and num2, called 3 and num1, they are declared as memory slots, and if either of the above variables is changed, the other is not affected. They each have their own memory slots. And so we can contrast this with how a reference data type is declared. And so if we create an object called D, the declaration creates a reference variable D that refers to a date object. The value of D is the address in memory of that object. So the variable D refers to the object, and it contains the month, day, and year. So if you create a new object called birthday and you set that equal to D as well, both of those variables will refer to the same date object. So if one of the variables such as month, day, or year is changed within the date object, it will also be changed for both D and birthday. And having references for the same object is known as aliasing. So since we have two of the same references for date here, both of these are aliases for each other. And so if we call d.changeDate, it will change the date for birthday as well. Next up, we have the null reference. So if we declare bank account B, it defines a reference B that is uninitialized. So since we did not initialize it, it is called a null reference or null pointer. And if you fail to initialize a local variable in a method before you use it, you will get a compile time error. Next up, we have method parameters. And so we have formal and actual parameters. And let's say we have a method inside of a class called withdraw. So the parameters string account password and double amount are dummy or formal parameters, and they are there as placeholders for actual parameters or arguments that will be supplied by a call to the method. So for example, when we declare a bank account B equals new bank account Tim B, 1000, we declare the actual parameters here, and account password and amount are actually the formal or dummy parameters. So we know that parameters are passed by value, and so this means that when a method is called, a new memory slot is allocated for each parameter. And any changes made to the parameters will not affect the values of the arguments in the calling program. So let's look at an example here called paramTest. So in this class we have a method called foo, which basically takes the parameters and sets them equal to a certain value. And then we have the main method, and inside the main method we have an integer a equals 7, double b equals 6.5, and then we call foo and place a and b inside of it as parameters, and then we print a and b. So one would think that when we print a and b, it'll print 3 and 2.5 because foo sets the value of a equal to 3 and b equal to 2.5. However, that's not the case, because as soon as we leave the foo method, the variables are restored to their original values, which are 7 and 6.5. So the output of this program will be 7 and 6.5. Next up, we have passing objects as parameters. So it is not possible for a method to replace an object with another one, and you can't change the reference that was passed. It is, however, possible to change the state of the object to which the parameter refers through methods that act on the object. So we have an example for this here, and in this example we have a method called chargeFee, and inside this method we take a bank account object called B and withdraw a certain fee from it. So we're able to change the state of the object by withdrawing a fee of 5 from the object. In example 2, we can see that we have a bank account. In example 2, we can see that we have a class called ChooseBestAccount. So this class basically attempts to set an object equal to another object. And this is not possible because the entire object cannot be changed. Only the state of the object, such as a variable inside the object, can be changed. So this will result in unintended consequences for the programmer. So the way to fix this problem is to modify the method so that it returns the better account. So instead of calling b1 and b2 after running the method, we return better from the method because the method cannot change the objects b1 and b2. So the first way of approaching this problem would not work. And so returning better, which is the actual object inside of the class, will provide the correct solution. So that's it for this chapter. Let's move on to the multiple choice. Questions 1 to 3 refer to the time class declared below. Number 1. Which of the following is a false statement about the methods? The answer to this one is D, because the time class only has 2 constructors and they can be found by their name, which is the same as the class name. And we can see that there are only 2 methods with the name that is the same as the class name. So this one is D. Number 2, which of the following represents correct implementation code for the constructor with parameters? So this one is B, because the constructor should give each of the private instance variables the value of their matching parameter, and the only one that accomplishes this is B, because the instance variables are hours, mins, and seconds, and they set them equal to the parameters, which are H, M, and S. Number 3. A client class has a display method that writes the time represented by its parameter. Which of the following are correct replacements for method body? So number 3 is C, because choice 3 prints it correctly because of the defined toString method in the class. So when we print T, the toString method ensures that it will be printed correctly. And choice 1 is incorrect because it doesn't reference the parameter lowercase t of the method. And choice 2 tries to access private instance variables, which are hours, minutes, and seconds, and fails. So 3 is the only correct answer, so the answer to this one is C. Which statement about parameters is false? So number 4 is C, because it says 2 overloaded methods in the same class must have parameters with different names. However, you can have methods that have parameters with the same name but different signatures. For example, if 2 methods have the same name and one has int x and the other has double x, the parameters are the same, but the signatures of the parameters are different. Questions 5 through 11 refer to the following date class declaration. Number 5. Which of the following correctly constructs a date object in a client class? So the answer to this one is B, because it is the only one that follows the correct syntax of first having a class name, then the name of the object, then the keyword new, and then referencing one of the constructors. So number 5 is B. Which of the following will cause an error message? So the answer to this one is C, because it will cause a null pointer exception since D is null, and 2 just makes both objects null, and 1 creates an object reference and then declares a second reference to the same object, which is allowed. So 3 is the only one that tries to call a method to a null object, and that will result in a null pointer exception. 7. A client program creates a date object as follows: date D equals new date 1,13, 2002. So the answer to number 7 is E, because it asks which of the following subsequent code segments will cause an error. And int y equals d.year will cause an error because it tries to access a private instance variable year, which is not allowed from the client side. Consider the implementation of a write method that is added to the date class. Which of the following could be used as implementation code? So this code basically just prints out the date, and 1 and 2 accomplish this, and 3 prints this, and that is correct because the toString method ensures that the date will be printed in the correct format. So the answer to this one is E, because they all work. And number 9, here is a client program that uses date objects. Which of the following is the correct replacement for code to get birth date? So the answer to number 9 is A, because the first one is the only one that works, since the second segment tries to use accessor methods, and they only access previously defined variables, and we need to find new values. And the third one uses an attempt to access private instance variables over here, and that's not allowed from the client. Number 10. A method in a client program for the date class has this declaration: date D1 equals new date, month, date, year. So they want you to create a second date object, D2, that is an exact copy of the object D1, and they ask which of the following will not do this correctly. So the answer to number 10 is A, because segment 1 will only reference an existing object and it will not create a new one. Number 11. The date class is modified by adding the following mutator method, and which of the following will be true after executing this code? So number 11 is C, because recent date is defined as null in main over here, and so a method cannot replace an object reference, and that's what this method add century tries to do. However, it cannot, so the object remains null. Number 12. Here are the private instance variables for a frog object. Which of the following methods in the frog class is the best candidate for being a static method? So the answer for this one is B, because getPondTemperature applies to every frog object, which is what static methods are used for. Number 13, which of the following will be produced by this program? So this program has a method called strange method, which is used in the main class. So int a equals 6 and b equals 3, and then a call to strange method is used, and a and b are placed in it. So here x is equal to x plus y, which is equal to 6 plus 3, which is 9, and y is equal to y times x, and y is equal to 3 and x is equal to 9, so that equals 27. So this print statement prints 9 and 27. So now we have either choice C or E, and then the main method executes its own print statement, and the values of A and B remain unchanged in the main method because they're not changed outside the scope of strange method. So it prints 6 and 3, which are the original values of A and B. So the answer to number 13 is E. Questions 14 through 17 refer to the following definition of the rational class. 14. The method reduce is not a public method because C. Because the reduce method is not intended for use by clients of the rational class. It is only supposed to be used to implement other class methods within the class. 15. The constructors in the rational class allow initialization of rational objects in several different ways. Which of the following will cause an error? So number 15 is D, because there are no constructors with a parameter of a type double, so D will cause an error. 16. Here is the implementation code for the plus method. Which of the following is the correct replacement for more code? So the answer to 16 is E, because the goal is to return this plus R and leave this unchanged. And in order to do that, we have to first create a new rational object, then reduce, and then return. And E is the only one that accomplished this in that order. 17. Assume these declarations. Which of the following will cause a compile time error? So number 17 is D, because the plus method can only be invoked by objects of the rational class, and n is an int value. So that will cause a compile time error. Questions 18 through 20 refer to the temperature class shown below. 18. A client method contains this code segment. Which statement is true following execution of this segment? So number 18 is B, because we know that only one object is created because the keyword new is used only once in the code, and the rest of the lines create references to that same object, which is known as aliasing. So all of these T1, T2, T3, and T4 all represent the identical temperature object, and they are in degrees Fahrenheit because at the end it is changed to degrees Fahrenheit. 19. Consider the following code, which is the correct replacement for code to construct. So isValidTemp is static and can only be invoked by the temperature class, not the temperature method, and the only one that correctly invokes it with its class name is segment 3. So the answer to 19 is C. Number 20. The formula to convert degrees Celsius to degrees Fahrenheit is F equals 1.8C plus 32. So here we have which of the following correctly replaces more code so that the post condition is achieved. So the post condition is that an equivalent temperature in degrees Fahrenheit has been returned and the original temperature remains unchanged. And so in order for the original temperature to remain unchanged, we have to create a new temperature object and then convert that temperature. So choices 1 and 2, create the new object and correctly convert it to temperature by multiplying by 1.8 and adding 32. Both do these in different ways. And the third one is incorrect because it does not create a new temperature object and changes the original. So the answer to number 21 is, number 20 is D. 21. Consider this program. Public class count stuff, and then we have the code for the class. If the input value for n is 3, what screen output will this program subsequently produce? So inside the main method we have int count equals 0, and it is run through this for loop that executes the do something method, and so do something changes the value of count from the initial value of 0 to something else. However, when the value is changed to something else, it returns to its original value after it exits do something because it is then out of its scope. So outside the scope of do something, int count remains equal to 0. So every time that count is printed here, it prints 0. So the answer to number 21 is A. 22. This question refers to the following class. So we have an int object class, and this is the client program that uses the class. And it asks, just before exiting this program, what are the object values of x, y, and a respectively? So int object x and y are initialized to 2 and 7, as we can see here. X is initialized to 2 and y is initialized to 7. And so, and a is equal to y. So a also points to the same object. And then we run x equals some method of y. So just before exiting that, we see that x is still pointing to the int object, which is 2. And now ya object obj and ans all point to the same object, which has a value of 8, because ans equals obj and it was incremented by 1, so the 7 becomes an 8, and all 4 of those variables now point to this object. And after we exit some method of y, x gets reassigned, so the object with num equals 2 gets recycled, so this object simply goes away. And so we're left with 3 of the variables y, a, and x pointing to int object with a value of 8. And after we exit some method, it increments it by 1 again. And we're left with y and x all pointing to one object with value 9. So the answer to number 22 is A, because all of them equal 9. 23. Consider the following program. Just before the end of execution of this program, what are the values of x, y, and temp respectively? So in the main, x is initialized as 6 and y equals 8, and a and b remain unchanged. X and y remain unchanged outside the scope of some method, and temp is undefined in the main because it goes out of scope when some method is executed. So since we don't know the value of temp outside of the scope of some method, that's equal to question mark, and the values of x and y remain the same outside of some method. So they're equal to 6 and 8. So the answer to this one is C. So thank you for watching. That's the end of the multiple choice, and I hope this video was helpful.